Okay, so what I'm going to do now is not actually technically a lecture, but this is mostly doing some NFA to DFA conversions, I guess, in real time. One of my students requested it, and honestly, it's not a bad idea to kind of show the entire process. It is a lengthy process, so this is not going to be a short video. I'm going to use 3 examples from the book. One is covered in the previous slide set, so you can actually see that happen like throughout the actual slides. But this, I suppose, I will kind of show the entire process by hand here. But I don't expect this to be a short video, so I guess let's go ahead and get into it. And I'm going to swap over here to the desktop. I'll be actually present, so you can, I guess, watch me suffer as I go through this. But I'm essentially going to do 3 examples here. I'm going to have the original NFA I'm going to put over here, and then I will do the conversion process over here right to this DFA counterpart. I like this piece of software. This is a revised version of it. You can find all the source code on GitHub, all that good stuff. Instructions over here. Give me 1 second. It's just adding states, adding arrows, and clicking and dragging arrows. You can create curves and all that, some superscripts, Greek letters. It's honestly very, very simple instructions. It's not too hard to use. I like it quite a lot. I use it for a lot of things whenever I'm making any assignments or just doing any on my own. But on the left side over here at the monitor, I'm going to have the actual book so I can look at the original NFAs. So if you see me looking over here, that's what I'm doing. So first one is the one that is actually in the previous slides. So I'm going to make three states right here. So that is going to be a Q_1. That is a Q_2. Number 3. So we have 3 states here. And this is by far going to be the easiest one. Excuse me. So let's go ahead and get this one. You do a self loop here. Ooh, didn't want that. One over here. Here, kind of curve this out. We can drag this and curve this in just like they have it. It could be awful. It is what it is. So Q1, that's our accepting state. This is self loop A. That's A comma B. This is an A. This is a B, and this one, if I recall how to do it, should be X. Oh wait, I think it's a backslash. There we go. So an epsilon, so it's an empty transition. So that's our NFA, right? It's not too complex, not too bad. But now we're going to go through the process of actually converting this to a DFA. And that is a much more egregious task. We can see we have 3 states, so we know we're going to have a power set of 2 to the 3. So we should have 8 sets in our DFA counterpart. And it's just going to be kind of a sloppy mess to start with. I can kind of line these up a little bit. But until I start doing the process, I won't know the best way to manage this right off the top of my head. So do something like this. Now you kind of have like almost like a grid, so if you have them in line, they'll kind of snap to, but I'm just going to do what I can right here for now. It's don't look too terrible. Okay. Hopefully these aren't too bad if you have any problem with it, but I think the spacing here is pretty decent, because again, there's gonna be lots of arrows. So let's see. I think I'm just gonna use unfortunately there's no actual null. I can actually type null. Maybe does type null. I'll just type null. I can do 0 or null, it doesn't matter. Which the 0 had the actual slash through it, but it doesn't, so it is what it is. And then we can just go through and do 1. Next one is, oops. Remember, these are all going to be sets. So do I want to do Q1, Q2? What does that look like? Q_1. You know, okay. I'm gonna simplify that down to just 1 and 2 instead of Q1, Q2, Q3. As a matter of fact, I'll come over here and do the same thing. Generally, I like doing the Q1s, Q2s because it's just standard format. But in terms of doing this software, you can't change the shape of these states. And if I could make them more of an ellipses, I would. Unfortunately, they are just these static circles. So you're gonna notice as I get to this bottom right, it's gonna get kind of cluttered. I might even get rid of the actual roster notation as well, but we'll see. Matter of fact, I can tell that right now. What is it gonna look like if I do 3 here? That's kind of full. About 4. Is that extending? Yeah. Okay. Yeah, we're gonna get rid of the states. We're gonna simplify this down really hard. Now, normally you would want to have, the Q1, Q2, the roster notation, all that to indicate these are a set of states themselves instead of just static states. So, but for simplicity of this actual program, I can't change the size of these circles at all. So we're gonna keep it like this. 3. We'll do 1, 3. We'll do 2, 3. And then finally we'll do 1, 2, and 3. And you might wonder, like, why did I do 1, 2, and then not 3 here? Well, in this case, null hasn't appeared, so we're going to put that. 1 hasn't appeared, so we're going to put this. 2 hasn't appeared, we're going to put this. Now there's a combination that we made here, 1 and 2. Since I've already handled 1 and 2, this should be pretty simple. And then there's nothing I can actually repeat here, so we put 3, 1, 3 comes next, then 2, 3, and then 1, 2, 3. That's just the way that I know the book handled it. I'm going to try and keep it in line with that. And I don't think there's too much of a problem with it. You can set these up however you want. It's not a big deal. So first things first is our accept state is here at 1. So I'm just going to mark all of these as accept states. Okay. So we have that. Do I want to do null? We can start with null. Null's not too bad to start with. So let's see. I think it just loop itself on AB. I think this is where we start. There we go. I'm gonna pull this to this side over here. I don't think it'll be in the way of anything else. Okay. And then solo 1 by itself. Let's see. A input should go to null because it doesn't go anywhere. You can see right over here. You only have a B output from 1. So let's just go ahead and mark the A there. Where does B go? Just directly over to 2. Not a big deal. There we go. Put a B there. 2's A input goes to itself and to 3, so 2 is going to go to 3. So I'm just going to mark that as A. And then the B goes to 3. Tell on these lines that they aren't technically lined up, but it is what it is. Okay. Let's see. 1, 2. 1, 2. A input at 2 goes to 2, 3. 1 goes to 2 on B, and then 2 goes to 3 on B. So both of these. That's our AB. 3. Okay. Goes to 1. and to itself because we're ending on epsilon transition, so 3 could technically go back to itself here. If you end on an epsilon, we can actually accommodate that. Not generally if you start 1, because that would have to process A from 3 technically, but 3 goes to 1 on A, and then it can come back to itself by parsing nothing, so it'd be a free transition back. So A goes to 1 here, but the 3 goes to 1 on the A input, but then on the A input it could traverse back to itself, so it can go to 1, 3 on A. Make sure that is correct. Is there? Yeah. Okay. Let's see. B. Doesn't go anywhere. Ooh, that's not what I want. Go. Shift. Oh, come on, go to the side. There we go. There is no B output from 3, so it goes to null. It's perfectly fine. 1, 3 is next. Okay, this is kind of a weird one. Because 3 goes to A. 1, 3, A goes to null. So we don't have to worry about the 1 side at all. We just have to worry about the 3 side, but 3 goes to 1, A, 1, 3. So it's going to actually self-loop here. Maybe I put it here. Yeah, we'll put that there. After that, B goes to 2. What is it? What is that? What? Okay, there. That's what I wanted. Weird. Maybe I move this. I move this here. Yeah. 2, 3's next. Okay. So 2 on an A input goes to itself. It goes to 3. And then 3 goes to 1. So this is going to go here. And I already know something's going to happen, so I'm going to curve this up. It is actually going to be the B input. Where does B go to on 2, 3? 2 goes to 3. 3 does not go anywhere, so it just actually goes to 3. Oops. Go. And then finally, we have 1, 2, 3. A 1, 2, 3's A input is just going to loop back on itself because 2, 3 goes to A. 1 does go to null, but we don't care about that. We just know 2, 3. This portion here will go to 1, 2, 3. So we can just easily put that there. 1 goes to 2. 2 goes to 3. 3. There's no way to get back to 1 from B input, so it does loop down like this. All right. So that is our first conversion, which have accounted for every single state. That's a DFA because every single state accommodates the AB outputs just fine. You might be wondering, what happens to this epsilon? Why don't we have any epsilons over here? DFAs don't have epsilons. The reason that we need them in this case of how we are accommodating this is exactly like this right here. These combination states of 3, 1 goes to this, but you can never start at 1 or arrive at 1, so 1 technically doesn't even exist in the DFA if we're actually being truthful here, because our start state, I did not mark the start state. My bad. this is a start. And you might again think, hey, you said there's no way that we get to 1, the solo 1 by itself. And you can see right here, hey, we start right here. So what do you mean? Well, we don't just start at 1 because this is an NFA. We can start at 1, but there's always going to be this branch, so we also can start at 3. So instead of starting right there, we would, technically I'm going to curve this over here, and then click and drag. Right there. So you start at 1, 3, because that's always going to be a possible branch. So we can start at 1 or we can start at 3. We have that choice because that epsilon transition starts from our starting point. So that is our first place. Pull this back in a bit. So since we know that we can never arrive at 1, we can just delete that. Same thing, 1, 2, nothing goes to it. We can delete that. So we start here, and I can move about this entire process as much as I want. If I get rid of this null state, that is where an NFA, so if I got 3 and I parse the B here, that branch would halt. So this is what I like to call a trap state for DFAs, which basically means if you get an input, again, if you were at state 3 and you got sent, if you read a B, you would go here, and this would indicate that this current instance of a string that you're trying to parse will never accept because it can never get to anything else on any of these paths. It will be stuck here forever. And so that is the NFA, the DFA counterpart of just not having a transition at all. Now, everything else is fairly straightforward. These combination states are, again, kind of the equivalent of saying, hey, 2 has 2 outputs of A here, so 2 reads an A, it goes to both 2 or 3, and we just have its own quantified state. So we're trying to basically remove any form of, I guess, nuance or any form of ambiguity, essentially, on where you're going to go. That's the whole point of DFA. They're deterministic. They must be strict in nature. Every state has an A-B output. Nothing's missing, and there is no form of like free transition using epsilon. And again, this already looks pretty bad overall. Again, we already got rid of 2 states, but as we move through, you'll notice that things are going to get a bit worse. So let me go find the other one. Okay. So this is going to be also previous in the slides, but it was just the first thing of saying, here's an NFA example. Here's an NFA example, and here's the DFA counterpart. They didn't show the process, they just showed here's this and then here's this. They don't go through any of the actual conversion. They just give you the examples. And it's pretty awful, honestly. Well, in my opinion, I think it's pretty awful. And let me see if I can find it again. Yeah. Because what we have is just a linear line with 4 states, and the observing view will know immediately, oh no, that power set's going to be awful, and you would be right. So it's going to be 1, that's going to be 2, 3, 4 right there. And again, it's just a straight line. What could be bad about that? The other one is a whole triangle. It had a whole bunch of other things going on. Of course, the accept state. So we have a self loop here, 0, 1. I want these above. I like the software. It takes a bit of TLC to work. 0, 1, there's a 1, 0, 1, 0, 1. No epsilons here, no epsilons. Okay, so that's our NFA that we're starting with. And it is going to be significantly worse because the power set now has 16 states that we're going to have to cycle through. So double the amount because we're doing powers of 2 when we do a power set. So even if it's just one more state, that's double the amount of actual states we could be. So this is going to get absolutely hideous. I'm not really going to focus too much on cleaning these up because I already know from doing this previously that it's going to require some moving around as I go through with this, because these arrows are going to go all over the place. Now, I might end up doing some of the simplification during the process because it just makes life a little bit easier. I don't know yet. I know I did this a few days ago, so it's not like it's fresh in my head, but I just remember being pretty bad. Pretty bad. I'm just gonna pop these here. I think that's... Can't resize a canvas either. It'd be nice, but it is what it is. Still really good software, in my opinion. And that could just be the coping or the Stockholm syndrome. I don't know. So, okay. Start with null again. Just put it right there. I'll do a 1, a 2. Oh, that's not what I want. 1, 2, 3. 1, 3. 2, 3. Do a 4. Do a 1, 4. 2, 4. 3, 4. That's all those. I think a 1, 2, 3. A 1, 2, 4. 1, 2, 4. 2, 3, 4. And then finally a 1, 2, 3, 4. That barely fits. Okay. Again, this, if I did 5 states, I would not be doing this. This gets so bad so quick. This is again where like the real strength of an NFA shows itself. We have 4 nice little states, 3 transitions. Well, no, 4 transitions. Sorry, there's the self loop right there, and you're done. And you don't have to write anything on 4 because you just don't care what comes after it. It's accepting. It's done. And then you get, oh god, oh, it's gonna be so bad. So start. Mark all of our accepting states, anything that has a 4 in it. So these 3 here. That's you, and you. So any of these can be an accepting state. Thankfully, we still only have 2 characters that are transitions, 0 and 1. Because if we had 3 characters to transition between, we would have more lines. Maybe 3 outputs per state. So these scale in like the absolute worst possible way you can imagine. It is actually just so awful. I do somewhat enjoy this process in the same way that I would enjoy a puzzle like Sudoku and whatnot. It's just kind of like checking yourself, and not really math per se, but just kind of the actual pattern recognition of what's going on. So I can find some enjoyment of it, but I can also accept the fact that, man, this is gonna be awful to manage. I don't know if those are all in line with each other. I'll find out later. Where do we start? Just 1. Self-loop onto itself. I guess this is also the only way to start as well, so we'll deal with the starting state later. We'll deal with that later. Let's see. I guess I just marked this self-loop here. Well, no. That's not a self-loop on 0, 1. There's a self-loop on 0. Let me mark that. But it goes to 1, 2. Oh, it's so bad already. Hold on. pull these down a little bit. Because I need this arrow here with a 1, because 1 can go to either 1 or 2 on a 1 input is literally the only occurrence of a duplicate. So some of this isn't going to be too bad. That's okay. Let's see. 2. Yeah, because we have the 0 and the 1, so now we're on the 2. Just 0 and 1 both go into 3. This one may not be bad. I might be misremembering something. Well, I mean, it's going to be bad because there's like 1,000 states. It's only 16, but I bet if I probably never hurt anybody, I guess. Pull it down a little bit. There we go. So 2 goes to 0, 1. I can already tell that this branch is done because nothing will ever arrive at just 2. That will halt, and anything that would correspond beyond it will also halt because this branch can never happen. I'm not going to do anything with it right now. We'll come back to it later. Now 1, 2, because this again, I think I will go ahead and mark this. Start. You know what? I'm just going to put S for start because it'll clean up a little bit. And I will actually move this here and just pull this right there. I think I put start there. Yeah. I think that's good. I don't... Thinking. Yeah. Alright, this is ending with 1 followed by 2 characters, I think. What's the book actually say? Let me see. Yeah. This NFA is recognizing any string where the third to last character is 1. So you can have something like 100, 101, 110, 111. Do find it interesting. It doesn't loop back, but eh. All strings. 1 in the third position from the end. Oh, that's why. Okay. Doesn't need it. That's why this is so awful. This 0, 1 will create branches that have an infinite amount of actual characters at the front, and it will simply only ever exit on its actual correct guess. The NFAs will always make the correct guess, not because I guess they do have some form of intelligence in that sense, but it's because you were spanning a near infinite amount of actual branches. 1 will always be an acceptable string if it's going to be a possible acceptable string. So yeah, I could start 1, 0, 0, and then be completely done and halt here. And we're going to have all these 4s go back to null to indicate that those branches from the NFA, they all halt. Those ones are all dead. The ones that are continuously looping up here at the beginning, those ones are still alive and they can take the correct path from there. So again, this is where the complexity of NFAs come from. You can loop here like a million times if you want to. You don't have to. You could exit at any point, and those non-deterministic branches will all halt when they get to 4 because it takes no inputs. Well, you're going to see that reflected in the actual DFA once this is completed. Again, this is a lengthy process for a reason. So anyway, all that aside, I wanted to make sure I had my bearings before I get to even the second row. 1, 2, the actual path that we will continue to follow. Where do you go? Well, on a 1, you're going to go to yourself on 1 to 2, and then at 2, you're going to go to 3. So we're going to go to 1, 2, 3. It's good software, I promise. I actually just hit caps lock, I think. You have to hold shift and move around, but it is what it is. 1, and then on 0, 1 will go to itself, but 2 is going to go to 3. So we go to 1, 3 over here. So that's my 0 input. Okay. 3, well, 3 only goes to 4 by itself, so this is where things are going to get hideous. And it's honestly kind of nice because I know that this whole branch is straight up just going to halt. Because again, we can't get to nothing here is ever going to get us a 2 by itself. Because we'll always get to a combination of 1, 2 on that one input. Because the only thing that goes to 2 is 1. But since 1 goes back to itself, we will never arrive here. So this branch, once 4 comes back to null, that whole branch is going to halt. We don't have to care about it. I'm going to keep it up for the time being just because it's complete. But you will notice it's going to make life so much more difficult when drawing all these out. 1, 3. Okay. 0 input of 1, 3 is 1 goes to itself, 3 goes to 4. So it's going to do a 1, 4 on the 0 input. And 1, 3 on the 1 input is 1, 2, 4. Which is way down here. It's so bad. Oh, it's so bad. 1, 2, and then 3 goes over to 4, right? Alright, 2, 3 is 3, 4. Yeah, that's... of course. This is an annoying part because all these things are going to start crossing over the actual characters just like it's doing over here. There. I'm trying not to have these inputs and whatnot like overlap. It's not going to be readable to begin with, but it just makes me feel better. Okay, that's actually just going to be a 0, 1 transition. 2, 3 will always just go to 3, 4 no matter what. It's always going to progress. I don't think anything will ever send us a 2, 3, so I'm pretty sure this whole branch by itself is just irrelevant. 4 just goes to null. Nothing will ever get to 4 though. It doesn't take any inputs. Make sure I'm right on 2, 3. Yeah, 2, 3 will always just progress, but nothing will ever take us to 2, 3 because of this single 1 right here. That's fine. 1, 4. This does actually matter because we can get from the start state over to 1, 2, from 1, 2 to 1, 3, and then 1, 3 to 1, 4. So this one is relevant. And is also going to be the first one that will possibly... no, I don't think it'll take us to null. Maybe it will. I don't think it will, though. Where does 0 take us? Actually, since 4 is guaranteed to take us to null, we just have to look at what 1's going to do. So 1's 0 input. This will take us to 1. This is what actually creates the loop. Ooh, don't do that. Oh, it's so bad, man. Sure. 1. We're on 1, 4, but we know 4 doesn't do anything, so we don't have to worry about it. We just look at what 1's doing. To 1, 2. Yeah, this is the idea that gets us into that loop. 1. Two, 4. Again, this should just be the exact same thing as 2, which means I don't have to really worry about it because, well, nothing will ever arrive here. And this is the point where I said I was thinking about I might just clean up this entire process as I'm going because I am still 7 states that needs to be dealt with and nothing has changed. It is still awful. So 2 goes to just 3. On 0, 1. And again, anything that goes to 3 here, we can't do anything with it. So 2, 4, just like 2 here, and everything else subsequent to it is going to be deleted soon. So maybe the bottom part will be a little bit better. 3, where does 3 go? It just goes to 4. And the 3, 4 doesn't do anything, so this is just going to be halted here. Okay. That wasn't too bad there. 1, 2, 3 is going to be bad. I think we're going to start going down here though. So 1, 2, 3. On a 0 input, 1 goes to 1, 2 goes to 3, 3 goes to 4. I believe that is correct. So 0 can get to every single state. 1. Oh, it does not go to. I'm sorry. 0 goes to 1, then 2 goes to 3, 3 goes to 4. So 1, 3, 4 actually. I didn't write that down. I did not realize this. That should be 1, 3, 4. I apologize for that. That's in the 0 input. The 1 input is 1, is 2, is 3, and is 4. So that's the one that goes to 1, 2, 3, 4. The 1. Get over there. There we go. 1, 2, 4 is just gonna be what 1, 2 does because 4 doesn't do anything. Where's 1, 2? Where are you at? Ooh, I don't like that. Oh, you gotta cycle back to 1, 3, aren't you? Dang it. Alright, 1, 2, 4, 1 on 0 input, and then 2. You're gonna cycle back to 1, 3. More of the actual loop. And on a 1, 1, 2 goes to 1, 2, 3. Ooh, I don't like that. 1, 2, and then 2 goes to 3. Yep. It goes here. I will pull this and pull this a little bit. Maybe I won't. Yeah, we'll keep that. That's 1, 2, 4. 1, 3, 4. 0 input is 0. That's 1, 3. Where's 1, 3 go? It's a mess. Okay. 1 and then 3 goes here. So just 1, 4. Okay. So 0 input. 1 goes to 1, 2, 3 goes to 4. So 1, 2, 4, I think. That's where this is gonna go. 1, 2 from 1. That goes there. Yeah, because 1, 3 goes here. And 0, 4. Yeah. That makes sense. 1 input, 2, 3, 4. Where does 2, 3 go? Oh, it just goes to 3, 4. Because both of these, because 0 doesn't do anything, so okay. And then 1, 2, 3, 4 should just go to itself on both of these, because 1, 2, 3, 4 is whatever 1, 2, 3 does, actually. Oh, okay. So, oh, right, because there's no way to get to 2 from 0. So you're 0, and a self loop of 1. Alright, that is the complete DFA without anywhere near enough space because there's 16 states all trying to get to each other all at the same time, and it looks like an absolute cacophony of madness. But we can simplify this. Okay, so I know there is nothing there. Okay, let's just do this. There is something leading to null. I should actually have all. No, this is the only thing that leads to null. Okay. Right, okay, I see. Let's do this. We'll deal with null later. There is something coming to it, so that's fine. 1, there are things coming to it, specifically and most importantly, the start state. 2, nothing's coming to it, delete it. 1, 2, from the start state we get to there, that's perfectly fine. 3, 2 is coming to it, nothing's coming to it now besides 2, 4. We'll come to it later. 1, 3, 1, 2 goes to it. 2, 3, nothing is going to 2, 3. We delete that. 4 has 3, 4 coming to it. 1, 4 has things coming to it. 2, 4 has nothing coming to it, so we can delete that. 3, 4 here has something. 2, 3, 4 is coming to it. 1, 2, 3 has something coming to it. 1, 2, 4 has things coming to it. 1, 3, 4 does. 2, 3, 4 does not. 1, 2, 3, 4 does, but we need to re-go through because we deleted some stuff. This is all still good. 3 no longer has anything coming to it. 1, 3 does. 4 does. 1, 4 does. 3, 4 no longer does. 1, 2, 3. 1, 2, 4 does. This does. This does. 4 does not now. We don't have left 1, 2, 3, 4, 5, 6, 7, 8, 9. We can get rid of this. Now I can kind of clean up this a whole mess right here. Let's see if I can make this a little bit more tolerable. Because while this is still pretty hideous, this is actually more along the lines of what we're looking at. And it's really this big mess in the center here that's kind of hard to keep up with now. There's probably better ways of handling that. This guy. I think putting this down here. Oh yeah, I like clearing up a good bit. Like this goes back over there, kind of is awful though. It is what it is. Again, it's a DFA. We could restructure a whole bunch of this. I'm not seeing the pattern that gives us the best result right now. But if you look at the actual what the book has for its thing, I can actually pull that up real quick. Let me see. Let me pull this over. This is what we started with, and this is what they have as an ending point. And like it's way more, you know, simplified than mine. However, this is still a whole lot going on internally of all these loops and everything moving back and forth. It's 1, 2, 3, 4 accept states. Do I have 4 accept states? 1, 2, 3, 4. Yes. So this is, again, is a correct representation of what they have. It's kind of hideous because of what it started from, essentially. I could clean it up a lot, but we're not going to do that right now. Instead, we're doing a third one. How long is the video right now? 45 minutes in. We have another 4. Okay. So let's take a look at what I'm pretty sure is going to be a hard one, I think. Yeah, this one's going to be a little bit harder. It's going to have 4 states again. But this time we are adding an epsilon transition to the mix. So that's going to be fun. Real quick, let's just move this over. Let's just do 1, 2, 3, and 4. These all connect. Not a big deal. Self loop on this one. Clean that up a bit. And a self loop back over here. 4 is our accepting state. We have 0, 1. And we have another 0, 1. Let's see. This is just a 1. Move that up there. Same thing with this 3, 4. That's just a 1. It's the 2 to the 3 transition here. That's a little bit different. So, gotta go up there. Yeah. So again, we have our epsilon transition here. So 0 epsilon is our 2 to 3. So before we actually move on to, doing a conversion, let's just take a look at what's actually happening in this NFA here. So we have 2 loops here. So we clearly don't care about the length, both at the beginning and at the end. So clearly what we're looking for exists in the middle of our string. So again, we could start with any number of 0 and 1s and end with any number of 0 and 1s. So substring here. 1, 0, 1 is the obvious. So static 1, 0, 1 is guaranteed. What throws a wrench in the mix here is this epsilon. So it can also be 1, 1 by itself. So we're looking for either 1, 0, 1 or 1, 1 in our string. That is essentially the idea that we're looking for here. So all that being said, let's move on to the DFA. So again, we have 4 states in this one as well, so we're looking at 16 again because it was so fun the first time. Let's see, that's 4. Here we go to 8. Let's do 12, and then just mash out these last 4. Let's clean it up just a little bit, and then we'll move on to this oh so fun process. Okay. Big gap there. Drop that down. Yeah, again, it's not great, but it's cleaned up a decent amount. That's good enough. Okay, let's go ahead and label things. Got null again, that's 1, that's 2. 1, 2, 3. 1, 3. 2, 3. That's gonna be 4 right there. Then we'll have 1, 4, 2, 4, 3, 4. Oops. 1, 2, 3. Let's go with 2. Keep forgetting the comma. It's 1, 2, 4, 1, 2, 3. 1, 3, 4 this time. Don't mess up. 2, 3, 4, and then again, finally with 1, 2, 3, and 4. All right. So we have our actual 16 states here. Null again is just going to go back to itself. our start state, since there's no epsilon right here, is still going to be just 1. And we start the process all over again. So let's see, where does 1 go in the 0 input? It's just going to cycle back to itself, right? Yeah. Then it's going to cycle back to itself on a 1 input, but it's also going to go over 2, so we can just go ahead and start the fun. I'll drag it over here. So 1 will go there. That takes care of 1, 2. 2 is where things get a little bit interesting. Ooh, wait a minute. No, things don't get interesting there. Things get interesting now. Right. So if we look at this NFA, we can already tell that we are going to be moving from the top rank up here down to these bottom 2 ranks very, very quickly. Partially because this 1 does not go to 2 states, it goes to 3 actually. So 1 goes to itself in this cycle, 1 goes to 2 on this direct link here, but since the string that we're parsing here ends with an epsilon, it will also go to 3. So technically what we're going to is 1, 2, 3. Like so. Now it's gonna be really fun. Okay, 2 is where things also get kind of weird, because you might say, oh, well, technically 2 could go to 4 in a 1 input if we start the epsilon. When it comes to making the DFAs, you only do the epsilon transition if you end the string with the epsilon, not if you start. Because 3 would go to 4 on 1, not 2 going to 4 on 1. That's just to keep that cleaned up. So 2 on 0 goes to 3. It's so easy to do that. 0 goes to 3. And it just goes to null. On 1, it's already getting hairy. Okay, so 1, 2. 2, as you can tell, is probably going to go away pretty soon, because there's no way to actually really get to 2, because 1 is going to go to so many places, and there's no 0 transition here. So this branch here is probably going to terminate almost immediately. 1, 2 though. Well, you're gonna go to 1, 2, 3 at the very least, because on a 1 input, 1 goes to 1, 2, and 3. So, yeah, we'll do that, and then it's actually 1 goes to itself on 0. And it's going to go to 3, so I think we have 3 on 0. Maybe I can clean that up a little bit. Oh yeah, that works. Just put it below the line. Alright. Ooh boy. 3, just 3 by itself. Yeah, it's just gonna go straight to null on a 0 input. And then directly over to 4 on a 1. Ooh, too far. Right there on a 1. So 1, 3. Well, we know that we're, oh wait, we're not going to 1, 2, 3. We are actually going to 1, 2, 3, 4, because 3 can get to 4. So we already have a line going to the very bottom. Very quick. 0. Looks like it's gonna be the same thing as just 1. Which, well, yeah, it just goes to 1. Right? I think that's the case. Just, ooh, what is going on there? Oh, I grabbed the line below. I see. Pull this aside. I know it's a really long one, but I just don't want to get kind of crossed up on. these right here. That's a little bit cleaner. It's still pretty bad, but it is what it is. That needs to be a 0, not a 1. My bad. Yeah, so that's 0, and then the 3 doesn't really go anywhere, so it just goes to just that. So 2, 3 on that. Where we go there? 2, 3 is 1. Goes to 4. So strange. 2, 3 to 0 just goes to 3. Okay. And then 1, 4. That 0. It's just gonna loop back to itself, right? Because 1 loops back to itself on a 0, and then 4 loops back to itself on a 0, so it just doesn't go anywhere. Which makes sense because the loop's right there, but 1 looks like it's a 1, 2, 3, 4. It just goes everywhere. Okay, yeah, because look at it. 1 here loops back to itself. 1 goes to a 2. 1 also goes to a 3 thanks to the epsilon. And then 4 over here will have its own self loop. So this time, you are actually way over here. Okay, so either you stay exactly at yourself or you go to everything. Sure. 2, 4. Let's do the 0 first, because it looks like that's just going to be a 3, 4, so right next to its neighbor. And 2, 4's 1 is just a 4. Yeah, it's just a 4. That branch right there is not going to be, nothing's arriving here, so it's probably going to go away pretty soon. 3, 4 just goes to 4 on 0. Nothing exciting there. Oh, it just goes to 4. And no matter what, 3 goes on it to 1, and then 0, 1 goes to 4. So like it's just gonna go to 4. I didn't mark my accept states. I'm sorry. All over 4s. I was wondering why something looked kind of empty here. Not bad. 1, 2, 3. That's gotta go. Yeah, that's definitely going here on a 1. Okay, come on, get to the side. 0 though. Well, see, we have no way of getting the 2 on a 0, so I think it's just gonna be 1, 3, 4. Right? 1 can get to it on 0. 2 gets to 3. Oh, wait a minute, it's just 1, 3. 3 doesn't go to 4. So there's 1, 3. Okay. That is such an awful spot to go. Alright, cool. Can I pull that? Yeah, it's a little bit better. Man, I don't like that. 1, 2, 3 on a 0. 1, 2 goes there. 3 doesn't go. Yeah, and that's it. I just don't like it. 1, 2, 4. 0's input is 1, 3, and 4. So just to its neighbor on the 0 input. Is this everywhere? Well, yeah, because 1 goes to 1, 2, 3, 4 will loop back to itself, so yeah. Way at the bottom. Okay. Yeah, I think we pull up to the top, that's good. Alright. Oh, how'd you not get marked? I think I actually unmarked them. Oops. 1, 3, 4. 1, 4, so just 1, 4. On a 0 input, because 3 doesn't do anything, it's just 1 and 4, and as you can see, 1, 4 just goes to itself, not a big deal. It's the 1 that's going to be curious here, because I think that's just 1, 2, 3, 4. Because 1 goes to 1, 2, 3, and then 3 and 4 both go to 4, yeah. That's just going to be another 1, 2, 3, 4. Should be a bunch of those, apparently. Really curious how the simplification of this is going to look. A lot of things are gonna go away. 2, 3, 4. That is a 3 and a 4. So 3, 4. Looks like that's where we're going here. On a 0. That only goes to 4. On a 1. And then I think 1, 2, 3, 4 is going to be cycle on 1. But not on 0 because there's no way to get 2. So things be 1, 3, 4. On that. Is that correct? On 0, we'll go here. And 2 goes to 3. 4 goes to itself. So there's just no way to get to 2. So 1, 3, 4 is what we're looking at. Oh boy. That is pretty diabolical looking. It's so messy. Okay, so 1, 2, 3, 4. I want to make sure that that 0 is correct. 1 goes to itself, 2 goes to 3. So it's 1, 3, and yeah, that's it. Alright, let's start the simplification process. Null has things going to it. 1 is a start, so it's not gonna go away. 2, we can get rid of it. Nothing's going to it. Nothing's going to 1, 2. Something's going to 3. Something's going to 1, 3. Nothing's going to 2, 3. So many things are going to 4. Something is going to 1, 4. Nothing's going to 2, 4. Something's going to 3, 4. Something's going to 1, 2, 3. Nothing's going to 1, 2, 4. Something's going to 1, 3, 4. Nothing's going to 2, 3, 4. Lots of things going to 1, 2, 3, 4. And then rinse and repeat. Something's still going to null. That's the start state. It's not going anywhere. Nothing is going to 3. Something's going to 1, 3. Something's going to 4. 1, 4's got that. 3, 4 is empty. Yeah, 1, 2, 3 is good. Somehow 1, 3, 4 is good. 1, 2, 3, 4 is good. Null goes away. Which makes sense because there's no point this will ever really terminate in the NFA right over here. Besides, I guess, well, no. That would still have somewhere to go, basically. Yeah, it gives you an epsilon. Yeah, that's fine. Oh, forward is completely empty. Is that it? Let's clean that up. So what is happening down here? because it's pretty clear what's happening in the top. And remember, we either need 1 0 1 in the substring, or we need a 1 1 in the substring. This will take a 1, can get a 0, and then a 1, and it'll accept. If it gets a 1 and a 1, it'll accept. If it gets 1 0 0, we restart back at the beginning. What's really weird here to me is this whole process. I mean, this works. This is perfectly fine. A 0 goes here, 1 comes here. It's always gonna be looping on these inputs. If 1 3 4 gets a 0, then other loops on a 0 here, and then passes a 1. The thing is, everything down here is just once it hits this accepting state, it's gonna stay accepting. So if I wanted to, I could simplify this a bit more, just on logical assumption, and I mean, just again, identification that this is always going to accept. I can get rid of these and turn this into just a 0 1 loop. And then the moment that I get either of my substrings, either again 1 0 1 or 1 1, I'm guaranteed to accept. So it's not exactly inelegant, but it's definitely a way to do it. Look at that, I'm gonna make an actual genuinely decent looking DFA. And it's really not super complicated. The whole process there, again, it's messy, it's long, there's 16 states, you have to deal with everything. It's a tedious process like that. I'm not saying that. But this final result looks significantly better than the previous one, so there's that at least. I would say looking at this, the NFA here, and the DFA, I think you'd be able to derive what's actually happening at this state, essentially. I don't think anybody have a problem with that. Yeah, no, I think it's pretty good. All right, so again, as I've said, like NFAs and DFAs, they're both fairly complex in their own rights, and obviously the more you scale up an NFA starting point, so again, we've only dealt with one that has 3 inputs, no, 3 inputs, 2 inputs, 3 states, and then 2 inputs, 4 states. The 3 states was up to 8 because we have 2 of the 3, and the moment you add even just 1 state, it doubles the amount that you're actually going to deal with when dealing with the power set. If I did 5, we'd have 32 states. If I had 3 inputs, there's now 3 lines out of every single state for a DFA. So things scale up pretty quickly. So if y'all want to do a 5-state one, go for it. I'm not doing it here. The canvas on that website is way too small. Still, I really like the software. I think it's really good software. So much appreciation to the people that have worked on it, but that canvas size is too small for 32 states in my sanity. Anyway, this has been a very long video, way longer than I usually do, but I hope that this is helpful. I hope that it was worth it, and more importantly, I genuinely do hope that if you stay for the whole thing, or even if you glance through it all, that you got something out of it. That's the entire point here. So, without further ado, that's all I've got. See you next video. Have a good day.